Hello everyone. This is day three of writing 15 smart contracts in 15 days. Today we will be writing a very interesting smart contract, that is a lottery smart contract. Right. So I have prepared a brief rough diagram of how the things will be working under the hood of the smart contract. So in order to write a smart contract for lottery in which all the players like player one, player two, and player three can actually deposit some amount of Ethereum into a contract, and actually there's a person who can pick up a winner and actually allocate the winning amount to that player. So for this, the first and the foremost thing which we need in our contract is a manager, right? And along with it, we need three players. So we will be storing this three players into an array, right? And this manager will be deploying the smart contract, right? So in this smart contract, we will be having uh, s- something around six functions. So first function will be to enter, by which all the players over here can enter the lottery, and for which they have to pay zero point 0.1 ETH, zero point 0.1 ETH. And then we'll be having a function called get players, which will be returning all the players that join the lottery system. And then we will be having a pick winner function, which will be only be called by the manager who's deploying the smart contract, right? Which is message.sender, right? And in this pick winner function, we will be selecting these players randomly to allocate them as a winner, right? So how is this happening? Three players, let's say, are depositing zero point 0.1 ETH into this contract. So this contract becomes loaded with say zero point 0.3 ETH, 0.3 Ethereum, right? So this is a escrow contract, right? And whenever this pickup function is being called by the manager, a random player is being picked, and say zero point 0.3 ETH is being transferred to this player, the player which is being selected randomly, right? So this is a nice contract. So let's get into coding up this smart contract, right? So let's go. So over here, I have my project set it up, a Hardhat project set it up. In case if you don't know how to set up a Hardhat project, you can refer the video which I have made on setting up a Hardhat project. Okay, so let's quickly start writing up our smart contract for a lottery system. So in order to write a smart contract, we first have to give the license identifier. So I'll be giving the license identifier, SPDX license identifier. Now I have to actually mention with which with which version of Solidity I need my Solidity code to compile with. So I will be doing that using Pragma Solidity, and the version which I'm using over here is 0.8.28. Okay, so I'll be mentioning that over here with a forward arrow. Now, in order to write a smart contract, you first have to initialize the smart contract. So I'll be doing that using contract keyword, contract, lottery, right? Now, I'm getting suggestions, but I won't use it right now because I need full control over my code right now, right? So first, what we need is to store the wallet address of the manager who's actually deploying the smart contract. So how can we do that? We can store it inside address, address public manager, right? Now, then we need an array to store all the players who are participating in this lottery. So we can do this using address public players. Okay. Now, what I need is I will be creating a constructor which will be called uh, which will be called at a time when this smart contract is being deployed, and it will make the message.sender who is actually calling this smart contract as the manager. So we'll do that using constructor. I have built a constructor over here. Okay. And now what I have to do is make a function. Yeah, let me quickly see it over here. Yeah, now let's make a function to just give a entry to this players to our lottery system, right? So how can we do that? Let's just create a function, say enter, which is actually a public function, and we are performing some transactions, like we are sending zero point 0.1 ethers to that smart contract. So we have to mark this function as payable, and yeah, it was giving me suggestions. I'll take it. Require message dot value 0 point greater than zero point 0.1. Okay, 0.01 ethers. Okay, right. It will also work, but I'll do it like this. Okay, and so yeah, over here, this is the require case in which the amount of ether which the player with any specific wallet address is sending to our main escrow smart contract should be greater than 0.01 ether, or else there will be this message popped up that minimum amount to enter is zero point 0.1 ether, right? Now, what we can actually do is write a test script and actually register some players for the lottery, right? So yeah, let's do that. So for writing exceptions into our test cases, I'll be using Chai, and to actually interact with the Ethereum blockchain, I'll be using a library called Ethers of Hardhat, right? So how can we do that? I'll first do const, then I'll be expect require Chai, and then const ethers, sorry, require Hardhat. We don't need parse ether right now. So yeah, and now I'm having this test script for my lottery, so I'll be describing it. Okay, so we have our describe case as we have our test case initiated, and then now uh, what we actually need is the manager's address, right? So I'll define it, manager, right? Then what I need a wallet address for player one. So I'll be defining all the players. So let player one, comma, player two, player three. Okay. Uh, not lottery right now. And then now what we will be doing is we'll be writing the before each case. Why we write before each case? Because we need some lines of code to execute before every test case before every test case runs, right? So yeah, we'll do that using before each, not this dot before each, just before each. Okay, before each will be a async function, async comma function, right? Before each will be a async function. Okay, so now I will be actually connecting the smart contract, our lottery smart contract, to our test script. So let's do that. Const. Yeah, it's correct actually. So, okay. Async. Yeah, function. Sorry. Hmm. Let's just make it a arrow function. Yeah, good. Hmm. Now what I need is not manager.deploy. I'll actually define a variable and deploy it. So yeah, lottery equals to await lottery.deploy. Yeah. And then we will be getting the actual wallet address loaded with some amount of ethers using get signers. Right? We actually know that. We have been using this like every day, right? In this challenge. So yeah, this is pretty much it. No, no. First, now in before each case only, we have to we have to write the code for making the users enter into our lottery, right? So how can I do that? So await lottery dot connect. I'll be connecting player one, then I'll be calling enter function, and then actually I'll be passing the value equals to ethers dot arts ether, and I'll be giving it a value of 0.01 ether, right? And for we'll do this for player two as well. So player two, uh, and for player three as well, right? Okay, so yeah, this is pretty much it. Now let's make a it case returns player, comma, missing arrow function, right? We'll just leave this like this right now and just try to run this task script. Because I just made a small mistake over here. I just gave this greater sign over here, but we actually have to check that the value which the user is sending to the smart contract is 0.01 ether. Okay, so now this contract is running fine, and actually all the players can enter enter the lottery system using their wallet addresses and can pass 0.01 ethers to it. Okay, yeah, so it says it's passing, right? Now what we need is to check whether the player is entered or not. So we'll do that using function, then return enter returns entered players, and then we'll be marking it as public view. We are using view because we need to reference this array in order to perform this function, and it returns address. It returns an address, array of address, which is players, this players. Right. So yeah, let's just write the test case for this. So we will be able to do this using one, two, three, start. Okay, so we will be able to do this using this case. It lists all the players, right? And we'll mark this as async, and we'll actually get the array once players. What does this do? This will load the array of all the players who have registered using depositing 0.01 each to the contract. Away lottery dot get players lottery dot return entered, right? And we'll just log this console.log players. Now let's run it. Yeah, so we are actually getting all the three wallet addresses of the user who have actually deposited 0.01 ETH to the escrow smart contract. Right now, what we need is we need a function to pick the winner, right? Which is an interesting function, right? So let's quickly do that. Right? And we make a function to pick the winner, pick winner, pick winner, and actually over here we need to have a modifier as well. So we'll make that public. Okay. So why do we need that modifier? We need that modifier because we need this pick winner function to be called with to be called by onlyManager. So we'll have this modifier over here, and I'll mention this over here, which is only manager. I think. Okay. So I have the pick winner function over here. And now what does this function is doing? This function is actually checking that if there is a player in the array of the player listed, then only it will proceed the execution, or else it will be returning that no player is there for the lottery. And then we are generating a random index using text and ABI encoded package, right? We have passed a timestamp to get the unique identified random values in every 15 to 20 seconds, and we have passed a player's array to it. Now, what is this returning us? It is returning us a event integer, right? So now we need to convert this to a base value, right? So we'll modulo it with the length of the player's array, right? So which is what I have done it over here. For this function, I have taken a help of ChatGPT, right? So, but I'm actually able to explain this function for you, right? Right. Okay. So yeah, over here, then I'm having address payable winner, and then actually now we will be getting the winner out from that player's array, right? So this is the player's array, and we will be passing the index as random index, right? And now this is the most interesting part. What will be the price? The price will be the price which is actually loaded with all these three players, that is 0.01 ethers into 3, that is 0.03 ethers, is the price amount. That means the whole escrow smart contract will be transferred to the winner, right? So yeah, over here it says transfer and then price. And then after each round of the lottery, the players array will become empty, right? And an event will pop up, which will be returning the winner and the prize amount, which I have mentioned over here, right? This is the event which is called winner picked, right? So yeah, this is the smart contract. This is the function for pick winner, right? So let's just quickly write the test case for this. So for this, we'll be writing a test case, write a test case, and we can actually use AI to test our smart contracts, right? So yeah, it is giving me a good response, I think. Yeah. Yeah. So I will quickly get this test case on. Okay, so I have returned the test case for actually picking up the winner. So what it is doing, it is just connecting the manager to the pick winner function, and then it is actually recording the value for winner and the amount won, right? And then actually it is logging through all the events, right? From where it is logging from here, right? Because it emits both winner and the amount. Right. So from here, it will be catching the winner, and actually, the winner should not be undefined, right? The winner should not be kept undefined. And then once the event for the winner is being recorded, the winner is being logged over here, and the amount won is actually logged over here, which is the amount the extra contract is actually holding, right? And so let's quickly run this smart contract, right? Okay. Yeah, so we can see actually I should register three wallet addresses, right? So let's just uncomment this out, right? And run the smart contract. Yeah, over here I'm getting all the three wallet addresses from where the entry transaction is being happening, right? And it is displaying the winner correctly, right? It's being choose randomly, right? And the amount won is 0.03 ETH. right? Let's check that it is doing this randomly or not. So this is the wallet address right now. And yeah, it changes, right? And the amount get transferred to this, right? So yeah, this was the smart contract for the lottery system. Now tomorrow for day four, I will be actually writing a test script to deploy this on our local machine and run a blockchain on our local machine and actually deploying this smart contract onto that. Right. So thank you.